So thank you, Maren, also for your insight from an industry perspective. That brings me to one question from for Helen. Like, how do you foresee embodied and operational greenhouse gas emissions shaping, the product development in the facade industry, and if it does, how do you think that could shape?
So I think to shape product development right now, it's the drivers coming from regulation and codes. I mean, manufacturers right now are really stuck in a vicious cycle. I call it vicious product adoption cycle, because there are significant barriers to adoption of their technologies. As I talked about a little earlier, which means that it takes a long time to get new products adopted in the market. And so, to some extent, you have to wait for your competitors to catch up. I mean, in the US, we're often asked by designers for 3 equivalent equals. So, okay, so if you come out with something new, you can't get it adopted until, others have done it too. And then, often they're asked for, 10-year track record. So you have to basically wait. You have small projects and you wait a long time to get that track record, to get people comfortable. There's lots of issues around that, which makes it very hard for investments to be made, or companies to make investments in new products when there isn't a requirement for people to use it. So what I see in the market right now is that there's certainly a focus on operational energy, not operational carbon, but operational energy in certain jurisdictions. So you're seeing the needle move in Massachusetts, in Vancouver, in Seattle, in certain places that are driving higher performance fenestration. And where that's happening, you're seeing high performance fenestration being adopted. And the market is starting to move. People are starting to redesign their curtain wall and window wall to meet the requirements in Massachusetts because it's difficult. But we have a whole swath of the country that doesn't require it. So, to me, it's really not a technology issue. We have the technology. We just to create well daylit solar control space, we're just not using it. And there's that price premium I talked about, because you can't get to the economies of scale that you need to get costs down. No, see, I'm kind of preaching to the choir over there. So, it's really a challenge. So I feel like the mainstream product development is going to be shaped by the regulatory environment. Now we're seeing, if I think very much on the commercial side, it's very much driven by codes. On the residential side, we've seen incentive structures and above code standards drive product development. You're seeing that with the Energy Star program, but that's just residential, where you have a very specific high performance standard and it's linked to tax incentives. So you see that driving product development. We don't have that equivalent in commercial. On the embodied carbon side, we're starting to see it move the market with the high carbon intensive products like glass. So California has the Buy Clean California Act, which is driving embodied carbon of glass, and you're seeing manufacturers bringing out new EPDs showing our embodied carbon, but it's not really from a mass market moved out to fenestration assemblies. Again, I'm thinking mass market. There's certainly I'm sure your clients are asking for it, but in the broader context, that's probably, the top 5–10% are probably asking. The rest, there isn't a lot of capacity in the market to answer that. So yes, so some places the needle is moving on lower operational embodied carbon, but it's certainly not uniform.
Okay. Thank you for that. That was quite directly lead me to a question to Chris. So does it play a role in the architectural design solutions, or what's your
Yeah, well, I address this maybe a little bit holistically from our client perspective. I agree with Helen. I think our clients are exceptional, and we're lucky to have them, that they're so advanced and maybe not typical for the U.S. And so it certainly does. I would say it's a prime driver in that way we're thinking about development, and we're starting to ask, I think, more advanced and better questions, right? So looking at the whole assembly of a window, from the glazing, but the frame, and knowing aluminum is very energy intensive, and looking at other options and comparing fiberglass systems or wood-backed curtain wall, and using data to inform those choices. Now, I think maybe where I can address a little bit is this movement that seeing at CGF, and hope to see it throughout the industry, going from doing whole building LCAs and acknowledging that the reason we were doing it was not, we're starting to see some code requirements for that, but it was really LEED. And as a rating system and as a tool, introducing those concepts and having clients wanting to get to platinum, it's like, we're going to have to do our first whole building LCA. And it was a little bit of a black box, and we didn't know what we were going to find out. We've been doing that for 6 or 7 years, have a good level of intuition, I think, so we can go into a design project and already know roughly what the big drivers are and where we're seeing, I think, more progress. So we're about, I think in the last year or two, we've been tracking this, about 30% of our square footage that we've designed, we've done whole building LCAs. And certainly we want to be 100%, right? But I think we're getting smarter too in terms of how we do those LCAs, because if we've done a whole bunch of steel frame or concrete or mass timber buildings, we have a pretty good intuition before even starting roughly what. So I've been a big advocate for whether or not we do that whole building LCA, and it's still a pretty intensive process. Our BIM models aren't clean. We're working better with contractors. They have good quantities, so by the time they're starting to count the materials and cost it up, we've been having more synergy in terms of doing whole building LCA from their quantities. But really, before we get there, when we're making those significant design decisions, using LCA thinking based on our intuition and framing more limited focused problems to be able to address these questions. So starting the program, the bigger the building, just if everything else is equal, the more embodied carbon it is, right? So really trying to get in, also the more costly. So optimizing on size, but then structural system, and having some deep questions with the structural engineer in terms of pros and cons of different systems, and also ways to optimize within them, making that selection. And where we're going is looking at tools. We have an internal tool, which is a little bit of a Frankenstein, and it's really just an Excel spreadsheet, but it's pulling in EPDs, as much as we can trust them, from different facade components. And architects, a big decision we make is, what is that wall system, what's it made of, how, and being able to pull in different data and optimize a two-dimensional wall section, and knowing that if we ever get around to doing a whole building, I'll say, if we optimize the structure, if we optimize the concrete, if we optimize the assembly, we're making those right decisions, right? So that we know whether or not we can quantify the whole building perspective, we've made substantial reductions. And I think, where I think the industry needs to get is having more of these tools. There's some pretty good ones that are public in terms of getting a picture of what the overall embodied carbon is. But when we start looking at those specific decisions around glazing, being able to get really functional tools so that designers can make the right choice easily, pulling and being able to weigh the pros and cons and focus those decisions, I think is where we need to get as an industry.
Great, thanks. Just by chance, do you have an idea about the ratio of operational to embodied energy? As for Germany, just to give you a first idea, we were talking about not very ambitious building, about 80% operational to 20% embodied. But if we come to like high performance buildings or something like it, it's 50-50 already.
Yeah. Well, and I think Germany might have an advantage over the US because you may have a more consistent energy mix over all your locations.
Yeah.
It's vastly different in the US, and that's one of the interesting things. We're doing a project for a really advanced tech client in Indiana. They have solar, but they sell all the RECs to other locations. So if you're buying RECs, you're buying it from in India to keep their grid dirty, right? And so huge amounts of operational carbon from there compared to California or Massachusetts. We have a tool called Carbon Scope that's our holistic benchmark for asking that, right? Because it varies based on whether it's a hospital, a laboratory, or multifamily. So we can get a good enough EUI, energy split, figure out where in the grid it is, where those energy mix, look at those statewide goals for decarbonization. And the embodied carbon, we start with, okay, here's the baseline average intensity, we can get better numbers. But I mean, we've had projects where it's 75, 90% embodied carbon and vice versa, depending on the project type and location. So having that tool actually helps at least sharpen our intuition going now.
Cool, thank you for that very interesting insight. Are there any questions from the audience? Are we okay?
I can ask from here. Do you see an increased use of solar concentrators for transporting light from outside the building inside, and also the light valves to sort of control that or modulate that?
I wouldn't say increase. We've looked at that technology and tried to integrate it in buildings. I think one of the dynamics, and we're trying to get experiential spaces and bring light in, but it's when we look, it's not necessarily a driver for decarbonization right now. LEDs are so efficient; it's more of a spatial amenity, I'd say, and quite frankly, it's we've looked at it but have not been able to get it integrated in our project. But
yeah, I would say something similar. It's something that comes up on projects occasionally, but what we found is just good daylight design from the start is much better than trying, like those kind of solar concentrators typically are meant to solve problems, or typically come up to solve problems where you got an existing space that doesn't have access to daylight, or you've designed a space in a way that doesn't have access to daylight. And what we find is it's just much better to design the space for daylight access in the first place, to avoid the need to use those sorts of things.
Yeah, I wanted to just expand on what Helen said. So first of all, in the US, we have a lot more policies for the residential sector for facades and glazings than we do the commercial. However, we do have right now a tax credit for electrochromic glazings, right? 30%, including the entire cost of the project, which is, defenestration and then installation. So it's a large amount of money. The problem is it's only effective for 2 years, which makes it hard to get started. So again, there's another tax credit we have in place. So that there are some policies in place, but the policies on the commercial side are so much weaker than it is on the residential side. The other thing too is if you look at Europe, right? When there's a lot of public policy debate, a lot of times you have the industry driving the policy, right? And so you renovate Europe, all these things are going on, and you see that happening. But in the US, our industry, they try here and there, but they're not as well organized, or they don't speak with one common voice when it comes to public policy. And as a person that's deciding upon, I'm not Congress deciding policy, but when anybody that decides on policy, they see 3 or 4 different versions coming at them, and it gets all confusing, and people are fighting among themselves. They're like, you know what? Let's go back to that heat pump industry because they got their act together. And so it goes back to industry getting its act together on affecting public policy.
I would also say one of the challenges is residential is ahead because they have a very clear definition of what good looks like, what good fenestration is. So the Energy Star is very simple. We don't have a definition of what a good facade is.
Yeah.
So we can't say, utility, please give an incentive for high performing facades or fenestration for commercial, because we don't have that definition. And it depends on the building type, it depends on not just the location, but a lot of different things. So it's just more complicated.
No, but that's a great point. But the definition is important, but also the metric, right? So
Right,
the ratings for commercial buildings are so far behind. We still have problems. We're still trying to get the new version of NFRC out. But the ratings for residential have been around a long time, and so it's very easy having all the ratings. The Energy Star makes it easy. So
I would also say that since we're here at LBNL, the three programs you just mentioned, heat pumps, LEDs, and electrochromics, were all driven by initiatives at the DOE labs. And I think the reason that the industry is so cohesive around them is because there's been excellent government leadership around those three specific things. The industry as a whole has taken their cue from the research that's come out of the labs. The labs have done a very good job of working with the industry in order to create useful metrics and sort of cohesive message about where the funding should go. That has not been the case with the facades, even though the labs have had long-term initiatives to develop high-performance facades. This sort of fractured approach of so many different things, because it's so inherently complex as a problem, but it also means that sort of cohesive voice that you're looking for as a funder is very difficult to find. And I think that one potential solution is a task force such as this, or task force within the labs, to be able to produce something that is cohesive, easily understandable, and then can be promoted in industry so that you have that synergistic feedback.
I think that also reflects on our findings that it's very scattered right now. The databases are scattered, the approach is very scattered. Also, the role of the policymakers guiding that thing, it is all very new, and it takes effort to bring that into application into the planning process right now, to make that livable, plannable, implementable. Cool. Are there any more questions from the audience? If not, then I would have one last question to Matt, talking about the EPDs, and we also heard from Maren quickly about the EPDs. What's your take on bringing that into the planning process? I mean, from the product into the system of building.
Yeah, I think, I mean, we're in sort of early stages of looking at that as data on projects, and I mean, just from the slides we saw, it's quite complicated. You know, there's A1, A3, B, like that's all this stuff, and to sort of figure out a way to incorporate that into a workflow when we're looking at what's the light level, what's the energy use, what's the perception of the space. How does it work with the ceiling? There's a lot of things we need to think about, particularly for electric lighting components. But I think thinking about it more broadly, what we've been focusing on is, I think, there's the embodied carbon in the production of the fixture, and I would expect that for similar lighting approaches, different manufacturers, different fixtures are going to be in the same ballpark of embodied carbon. But for us, what's important is what happens when that fixture fails, when it needs to be replaced. You have to throw out the whole light, which I think with the advent of LEDs, a lot of manufacturers have gone with an approach where it's just a thing that you buy, and when it is end of life, you toss it. And that's one of the things that we are trying to push manufacturers, and in the work that we do, trying to work with how we specify things to make sure that you don't have to do that. So I think I'm sorry, I'm blanking on the modules. The later modules of the LCA are actually maybe more important to us, because I think if you think about it through the life of a building, if you have to replace an entire fixture versus replacing an LED module, that's going to dwarf whatever energy savings you get from going to LED, or some difference in cost, LCA costs from this manufacturer that has a slightly different manufacturing process versus that one. It's really more for us, I think, about long-term maintenance, replaceability of light sources, and replaceability of drivers, and doing that in a way that's easy for an end user to do.
And if I could just expand on that for 1 second, just because I think it is a great point. It's something I'm really concerned about. In the US, at least, those EPDs, those product EPDs are A1 to A3. So it is cradle to gate. That you're saying it's the end of the disposable and the recyclability, and this idea that, like, it's great. I think at European, I was glad to see your industry studies looking at the entire life cycle, and we have to ask questions to designers, whether we're gonna use Module D, what's the end of life scenario? Oftentimes we don't know, but it's good to have that backup data, industry average. But I think it's a real question, particularly in the US, with product category rules being different here than in Europe. How can we get some generalized data, this end of life, and be able, because otherwise, if we don't have the data, it's not gonna drive those decisions for people.
Sorry, we have the same issue on the facade. So curtain wall has a certain life, and if you look at unitized curtain wall, if you could access, it's been designed to be good until it's not. When the seals fail, you can't get to them. You have to take the whole thing down. So we haven't as an industry really thought through design for sustainability. And so the lifetime, the serviceability, the ability to upgrade is a big gap that we aren't addressing. That really goes to service life, and nobody's talking about service life, which is really important. And a colleague at SOM uses this metric, which I think is great, which is embodied carbon divided by service life, which I think we should all start using more of, because it really helps to understand that balance.
I mean, it's somehow incorporated if you divide it by the lifetime or not. But it is sometimes and should be. Should be, and a lot of the EPDs in Germany are used also do cover also the operational for like the maintenance of the systems and stuff like that. I mean, and also having the Model C, but Model D often is just used informatory. So it's also with the funding programs, they require now an STA in Germany, but with our Module D, they only go A to C and D is. But I was interrupting you, sorry for that.
No, I think the service life is a big challenge, because at least in the US, if a manufacturer makes a statement about service life, there's a potential legal implication for implied warranty. So it's really hard to get good service life information from the industry. So that's a challenge that we need to get our arms around, I would say.
We also on that from the German perspective, if you apply for that funding programs, there are from the regulatory body given life cycle and also usage times, operating times, and how many times you have to replace a certain category at least to somehow cope with that.
Yeah, we've done the same thing. The EPD for Windows just has a generic 30 years in there.
I mean, just real quick on the service life. So in the US, if you look at the public policy for Energy Star, done by EPA and supported by DOE through LBNL, you know, we typically say the service life is 20 to 25 years for a window. Okay. However, when people do studies, you know, so many people leave the window in place well beyond its useful years. So it may be in service for 35 years. Okay. So if it's in service for 35 years and you're doing the public policy based on 20, that's not exactly fair. Right. So, and then when you start looking at comparing that to, let's say, a heat pump that gets replaced every 15 to 20 years. So you have to have 2 cycles of heat pumps for every 1 cycle of a window. Right. And so people aren't making those investments on the long term. Right. And so, and one thing on embodied energy real quickly. So we are doing a very comprehensive study on fenestration, glazing, embodied energy in the US by Argonne National Laboratory, hopefully out by the summer or the fall. But roughly just big picture, the annual production of glass versus operation of glass, it's 13 to 1. So operational energy is by far the biggest thing. And some organizations, it's all about embodied energy. I mean, embodied energy is important, but it's a very distant second level. Okay, we need to get low operational energy from facades because the vast majority in the US are very, very weak, and we just need to get them upgraded. We got half of the windows in commercial buildings in cold climates are single pane glazing. I mean, that's insane.
But exactly, no doubt you have to get operational. I mean, that's quite clear. But then again, if you move towards that high performance things, and we heard that also, then the embodied energy also gets bigger impact, and also looking at what happens within the 50 years you usually and can also then ask, especially use of daylight versus shadings with electric lighting, and that brings also those components in. So I think that is an important thing to that, the thinking and then bringing into this into the design. Cool. And as I'm now standing between you and the coffee break, I'm hoping to release that Barry, and thank you for the good discussion.